Where are my strategies? Okay. Open. Do you have your booklet? Yeah. All right. So check this out, folks. So I want everyone to take that little piece of paper that I gave you. Okay? Make sure you don't lose it, because for now, it's really helpful. Word problems can be super confusing. Okay? So the first thing I do, now, some people are more proficient at reading than others. I am not. Like when I would do English exams, it took me twice as long to like actually read the stuff, right? So I'm a slow reader, and so I can appreciate if processing the information while you read is difficult. I get it. And so for me, when I read word problems, the first time, you can't even see the screen, the first time I read the whole thing without highlighting anything, like all I do is I'm just reading, right? And then I read it a second time and I'll underline stuff. Okay. Or the first time I underline, second time I read through, but I take my time to process the information, right? Underline the given info, circle what you need to find. Step 3 is to decode the math term. So, like actually being like, oh, it says product. What does that mean? Oh, it says consecutive odd integer. What does that mean? Oh, it says hypotenuse squared. What does that mean? Okay. Draw a picture if appropriate. So if there's a shape or a path or whatever, I'm drawing a picture to help me understand what's happening. Step 5, declaring variables, right? So I don't do let statements until I get to step 5. Number 6, write the equation and solve it. Number 7, did you answer the question? Does my answer make sense? So we're going to do a check. And finally, when we're convinced we did it, a therefore statement. All right. So let's give that a shot. I want to finish this question first. So this is the question that we started. So, no. Sorry, Miss Lai. Yeah. Folks, I would like you to take the practice test and put it in your binder. Put it away. If I see someone working on it, I will take it away from you. You're doing a lesson now. All right, I think it's 10. It's page 10. Because we didn't finish the question. Okay? So we did a lot. Right? We were working on, so that's, yeah, so near the front of the, keep going. We were working on a question. Bring your phone here. Yeah. Pardon? Oh, to charge? Okay. We were working on consecutive integers. And if we're doing consecutive odd or even, do you remember we had to do the +2 situation? Okay. And then we were finding the product, right? So we said the product of 2 consecutive odd integers is going to be 195. But we didn't end up finding them. We're still on the solve part, right? We wrote the equation, we expanded it, and then we said we're going to use the quadratic formula. So we plugged in our A, B's, and C's, and we're at this point where we have that x equals -2 ± 28 over 2. Can everyone see? Charlotte, can you see? Elise? Okay. Melena? Okay. All right, so what that tells us is that x1 is going to be negative plus 28 over 2. And x2 is negative 2 minus 28 over 2. Right? That's the whole quadratic formula. It gives us two answers. So let's do that in our head. Negative, so 28 minus 2 is 26, divided by 2 is 13. Negative 2 minus 28 is negative 30. So I want everyone to pause here once you copy it down, and I want you to think about what we just found. So use your critical thinking. What did I just find? Did I find the answers? Am I ready for my therefore statement? Does it make sense? If I'm not done, what do I do? And, okay, so look at it. Okay, are these two my two numbers? 13 and negative 15, why not, Jules?
Oh, sorry, 195.
They don't multiply to 195. They don't?
I don't think so.
Try it out. I'm glad
No,
you're...
they do.
They do. That's one way. That's a good critical thinking strategy. Do they multiply to 125? 195.
Negative 195.
Audrey. Interesting.
Negative 1.
One of them is negative, and I'm kind of trying to figure out, what do I do with that? Is it okay? Like, yeah. Right. So if we're doing a product, that means the only way to get a positive is positive times positive, negative times negative. But equations don't lie. Quadratic formulas do not lie. Does anyone know what I found here? Yeah.
2 x's, but you have to add 2 to both.
Ooh, what do you mean 2 x's?
2
So I guess my question, Alex, is how many answers do I have for this?
There's 2 sets.
There's 2 sets. Guys, that's a big thing. We got to wrap our head around this. Both of these are right. What do both of these numbers represent? Which variable? X. Go back to the let statement. The let statement said, let x and x plus 2 be the integers. So if 13 is my x, what is x plus 2? Positive or negative? Positive. Positive 13 times positive 15. What if I say, no, in this case, my x is negative 15. What is x plus 2? What is it? Negative?
13.
Oh, so negative 13 times negative 15, still 195. Do you know why we have 2 answers? Because it's a quadratic. It's not a linear equation, right? When we do linear, we have one answer. Because how much times does a line cross the x-axis? How many times does a parabola cross the x-axis? So that's actually part of it, guys. There's 2 solutions. Okay? Sometimes we don't end up using the 2 solutions because if it says like the length of the triangle is negative 56, you're like, it can't. But in this case, it doesn't matter if it's negative or positive. So let's watch this. X plus 2 equals 15. And in the other solution, x plus 2 equals negative 13.
It's probably negative. Because what we're trying to find is positive.
So why don't we check? That's a great question. You're saying, won't the product still be negative? Tell me why it won't be negative. Multiplying 2 negatives gives you a positive,
Oh, wait.
right? So this is an interesting answer. Does it make sense that we have 2 solutions? Is it okay? Yeah. So we say the numbers are 13, 15, or negative 15, negative 13. Both of them will give us a product of positive 195. That's kind of cool. So guys, just take a guess. Anytime you do consecutive odd, consecutive even integers, how many solutions will you always have? You got it. You're always going to have two. Okay? Yes.
Is the reason that the second number is the 15 is because the first is still there because it's the x and the second one is the x plus 2?
That's right.
That's representing both.
Say it again.
Like,
Yeah, this is, yeah. Like,
both the x and the x
right.
plus 2.
So this is the x. This is the x plus 2. Yeah. This is the x. This is the x plus 2. Great clarifying questions. Yeah.
I did it, and the two answers I got were the x plus 2. So like I got blotted, and then I got negative 13 and 15 as my two numbers that came out.
Did you factor or did you use quadratic formula? And I wonder if you factored just incorrectly. You just put the negative positive in the wrong place. Check. No, it would, because then if you ended up with negative 13 as your x, then negative 11 would be your other number.
But yeah, if I got that on the test, I would kind of just like notice that and just add to instead of.
But if you're not solving fully correctly, you want to make sure you find that mistake. Yeah.
On the test, are we allowed to use either one, or do we have to, will there be specific questions?
So as you can see on the first test, and now I did explain this, right? So just be like, oh, I wasn't listening when she said it. That's okay, right? Just a reminder. In the first 4 questions, I will say exactly how you're supposed to do it, factor or quadratic formula. On the word problems, you do it however you want. Okay? All right, next question. A bit more wordy. So keep your cheat sheet of how to do word problems next to you. Okay? Let's do the first 2 steps, maybe first 3 steps. We're going to read it. We're going to underline. We might draw a picture. So let's have everyone sort of make sense of what the question's asking for. All right, so we're on page 11. Page 11. You want to read the...
For us, we're already up.
You're writing on the wrong page?
No, it was already page 11.
Oh, how come there's writing there?
No, page 11 was your page.
Can I see this? Sorry, so is everyone on page 12? So, okay, thank you. Sorry, my pages are off. So you are on page 12. Okay, so read the example at the top of page 12. Talk it through if you want. So, Michael, you want to be reading the question and underlining the info that's given and circle what you need to find. Yeah. Yeah. One sec. I'm writing it down. 244. I want you back. Okay. A lot of stuff here. Right angle triangle, hypotenuse squared, one side, other side. What does nearest tenth mean? How many decimal places? 1 decimal place. So this is a visual thing. So before I do my let statements, I'm going to draw a picture. So I'm going to draw my trusty triangle. And I'm going to give it a right angle because it says it's a right angle triangle. And I remember from grade 8 and 9 that when we're working with right angle triangles and they mention the word hypotenuse, I'm like, ooh, I think we're doing the Pythagorean theorem. So that means hypotenuse is always C. The other two sides are A and B, right? And then I have that equation that says A squared plus B squared equals C squared. So we can use this theorem to find the different lengths of a right angle triangle. Okay? Now, we know something about the hypotenuse. Is it fair to say, or is it correct to say that C, don't write it, tell me if I'm right or wrong. Can I say C equals 89? No, I can't. Read the question again. What is it? It says the hypotenuse whose squared length equals C squared equals 89. So what that means is C squared is 89. And I could say, okay, C is square root of 89, right? So that's a bit tricky. Okay, now we're talking about the other two sides. Second sentence, between the other two sides, one side is 3 meters longer than the other. So if I make one of the sides equal to X and the other side is 3 meters longer, what do I say? Great. It's not 3 times as long. It's just 3 meters longer. So I'm going to go, oh, it's 3 more plus 3. Okay, I think I'm ready to start. I'm going to go to my cheat sheet and say, what is the next time I'm supposed to do? Help me out. Look at your cheat sheet. What does it say? What do I do now? Everyone. Ooh, I love my good let statement. Okay, let's make it green because it makes me so happy. Let. I don't need to say anything about C, but I'm going to say let X and X plus 3 be the sides. Yeah. Yes. Okay. Okay, so the question is this. How do I put regular 89 here and not the square root? So what the question says, one second, Grandma, see you have a question. What the question says is the right angle triangle has a hypotenuse whose squared length is 89. So meaning if you take the length of the hypotenuse and you square it, it's going to be 89. So they told us actually what C squared is, right? 89 is C squared. And so in this formula, A squared plus B squared equals C squared, I can already put that C squared is 89.
So since it's already squared,
Okay, let me try to say it another way. If I want to find C on its own, I would have to take the square root. So I have this. I have C squared equals 89. And if I want to get just C, well, I take the square root of both sides, and I take 89.
So wouldn't you have
I understand that. I just don't understand how like C squared is 89. Because I thought like 89 squared.
Oh, no. It's not 89 squared. It's saying the squared length already is 89. It's not saying square, like the length squared is 89. So length is like 9 point something.
Oh, I get it. the hypotenuse of the squared length equals 89 meters squared. Why is it not a square? Yeah.
Why is there not a squared here?
Yeah.
Because it's already squared.
Oh, okay. So the 89 is the two other sides squared. So it's on.
What I suggest is, guys, let's do this question. Let's have you practice some right angle triangle questions. It might help to do it over and over. Like it might kind of be like, oh yeah, I get it. Like I overthought it. It might be the situation. All right. So we've done the let statement. We now have to do the equation, and we're going to do the equation based on the Pythagorean theorem. So Pythagorean theorem says the two sides, you square the two sides, you add them up. So one side, oh, we already said that's going to be x. And what do I do with the x? Well, I square it. The other side, I'm going to make a mistake. The other side is x plus 3, and I'm going to square it. And I want you to be like, oh, Miss Sly, you're going to lose some communication marks. Okay, so talk to the people next to you. Yeah, right? Help me out. All right, people, show me with your hands. Okay, show me with your hands. What did I forget? With your hands. Make the shape of it. Yeah. What are these? Brackets. Because the entire side is squared. Got it? The entire side is squared. Okay. So let's solve. We got x squared. So we first have to expand and then collect like terms. Now, I've got this x plus 3 all squared, and it looks like I'm going to make the very common mistake of what? Yeah, guys, this is going to be the mistake. No, Miss Sly. You forgot the middle term. And I forgot it because I didn't write it out like this. Or I didn't notice that it's a perfect square. I'm bringing the 89 over already. All right, expand, collect like terms, everyone. So I'm really happy to see people not copying me, but actually doing this on their own and checking to see if we're sort of on the same track, right? So really work independently, use your brain here. That's awesome. Oh, you forgot something very important, dude. No, you forgot something very important. I usually jump off my desk to remind students of this. I busted my knee jumping off the desk. I'm kidding. Sometimes I will jump off the desk just to be like, don't forget. So imagine Miss Sly standing on the desk, jumping off, and mid-air saying, common factor first. Okay? Because poor Jules is looking for factors of negative 160. You see how silly that was? So silly. All right, so what's the common factor, folks? Thus. That's right. Can I use quadratic formula? Yeah, but that's going to be a lot of work. Should I factor? Right, this one's easier to factor just because it's a short trinomial. Jules, stop. Well, I guess you just made a mistake. I should give you some points. How about 7? Is that good? That's a lot.
Yeah.
Okay. Anyone know the numbers? Okay, take your time. I'll ask in a minute. Yeah.
Oh, I know what
When
it
we're
is.
doing this,
Oh,
we
yeah.
leave the 2 out until the end, or do you want us to write that in front of us?
Okay, this is the thing. Oh, no, you definitely have to include it. Oh, you mean like it could disappear and then reappear?
Yeah.
No. Please don't. Yeah, I can be a bit of a stickler with communication. But I'm glad you told me that because I'll like be a bit lenient as you're relearning to include it.
We did, when we were doing this, we got the,
I mean, you could do this.
that's what I did.
You could see I'm dividing both sides by 2
Oh, no, what I do is I.
and then it goes away.
I get rid of it, and then I just draw an arrow at the end.
No. Come on.
That was easier.
How much work is it to write a 2? Come on. All right, what are my numbers? 8 and 5. Which one is negative? Well, the middle term is positive, so I need the bigger one to be positive. Great. That tells us, ooh, look at this. I have an X. I have an X. Hooray, I'm done. Woo, hoo, hoo. Am I done? Someone be like, no, Miss Sly, you're not. No. Thank you. Whew, such urgency. Okay, so I go to step 7 on my cheat sheet, which says, did I answer the question? Does my answer make sense? So we go all the way back to the top and we check what we circled. What were we supposed to find? What's the word? Give me the word. The lengths. I was supposed to find the lengths of the triangle. Folks, which one of these cannot be -8? Can my length be -8 meters long? No. Oh, that would be horrible, right? Thank goodness. So guess what? Do we have 2 solutions in this case? No. Even better. All right, so if 5 is one of my sides, my other side is x plus 3, right? So my other side is 8. Notice that the other number I found was -8. Kind of cool. Not a coincidence. And then the hypotenuse is 89. Do they want me to leave it as an exact term or approximate? Nearest tenth. Right? So we're going to punch this in our calculator. 9.4. Great, I'm done. No, Miss Lie, you're not. Therefore, with units. Therefore, the side lengths are, and I'll go in like shortest to longest just because that looks really pro. Are we in meters? I think we are. Maybe I'll double check. Are we? Yeah, we are in meters. Or you could say 5M, 8M, 9.4M. Put a box. Miss Sly, I worked so hard. Watch this. I want you to look at my answer. Give me attention. It's beautiful. We good? We are going to start the next question, but we're not going to solve it. But I want to do the first 6 steps. And then I'm going to send you to the boards afterwards. So 7 more minutes of your attention, and then you'll go to the boards, okay? Any more questions about this? Okay. Let's go ahead and read sample question 4. Active reading, underline, highlight. So do people understand what's happening here? we've got a picture. It's the size of a piece of paper, 8.8.5 by 11. We're taking a paper cutter and we're chopping off the same amount on each side. So maybe we're chopping off a full inch on each side, top, bottoms, left, right. So let's just see a picture of like what it was like before. So we start with a rectangle, right? This is a great question to draw a picture because the picture ends up looking different, right? So the original picture is 8.5 inches, right? I use quotation marks to show inches. Do we know the original area? I can easily figure it out, right? One times the other. Now, I'm going to cut a little bit from the top, same exact amount from the left and bottom and right. So, how can I I don't know how much I'm cutting, so what do I use to represent the amount of paper I'm cutting? Take a wild guess. Yeah, why not? Let's call it X. So if I'm cutting X from the left, how much do I cut from the right? How much from the top? Bottom? Same. So now I'm going to redraw this smaller rectangle in its actual size so we can label the sides. So I know that the new area is 58.5 inches squared. Now, the height used to be 8.5. The length used to be 11. Now I have to account for the fact that I'm cutting off parts. So if I look at this 8.5, how much did I cut from the top? How much? How much from the bottom? So how much in total did I cut off? 2x. Okay. How about the sides? Same. Okay. So 8.5 minus 2x. 11 minus 2x.
Would it be 8.5?
I can't hear you.
Would it be 8.5 multiplied by 2?
You got it. What would our let statement be? Let x represent, what does x represent? The amount we cut off. I'm going to just say amount cropped. Right? We really needed to think because it's not like the length. It's just how much we're cutting off. Okay, now we're not going to solve it, but I want us to write the equation. So I can use this middle information, this area information to write an equation. We're working with a rectangle. The area of a rectangle is length times width. Do I know the area? Yeah, I do. It's 58.5. Do I know the length? Not completely, but I know it's being represented by 11 minus 2x. And do I know the height? Yeah, 8.5 minus 2x. So how do we solve this? What would I do next? Talk to the people that you're next to. Daria, can you turn around? Or actually, Pierce, why don't you turn around and talk to Daria?
Can I just flip over so it says 11 minus 2x? Like, so the bracket equals 58.5. Can I move it on the other side?
And make the 58.5 negative?
No, can I just move it the same? Because I feel like wouldn't that be the same thing?
You want it swapped.
Yeah, no.
Yeah. You just don't like it to look that way. Are you guys actually doing this? Do it. I didn't, yeah. All right, so we're expanding, collecting like terms, and finding the value of x. Who thinks we're going to factor and who thinks we're going to use the quad formula? Say it out loud. Really? I think we're totally quad formulating it. Do you know why? We got decimals already, right? If I already have decimals, there's no way I'm going to have whole numbers for factoring. 58.5. Ooh, there's going to be ugly decimals. This slide does not want to think.
They don't get
Ooh, we might be able to factor. Okay, so we could use quadratic formula. We could factor, right? We're really looking for something that gives us 140. 2 and 70. Both have to be negative. Yeah. Ooh. Okay. So I can factor. Okay, so X could be 1 inch, and X could be 35 over 4, which is 8.75 inches.
Where did you get the 35?
Did I make a mistake? This
The 35.
35. Yeah. So I brought this over and it became negative.
Oh.
And then that's a great question. I was hoping someone would ask. All right. So I'm looking at this and I'm like anyone using their critical thinking, their math spidey sense and being like, something doesn't feel right. Like basically what we're saying, we take a piece of paper. If we cut the same amount off each side, we're going to have a certain area. How is it that we have two answers? We're going to cut different amounts from this paper and end up with the same area. Do you see how that's kind of, in my head, impossible? But we're cutting the same amount from each side. Look at that. Look at those answers really critically. So X could either equal 1 or X could equal 8.75. Come on, someone. Really try to see. Use your critical thinking. This slide will give you 7.5 bonus marks. What is it? What is it? What doesn't make sense? Good. I see some O. Good. That means we're thinking. Guys, use your brain. Like, really turn on your thinking brain and be like, what doesn't make sense? Who's like still unclear? Put your hand up if you're kind of like, I don't know. All right. Who knows which one the answer cannot be? Grace, which one do you think the answer cannot be? Don't tell us why. Grace says 8.75 cannot be the answer. Get a head shake from Juliana. I agree. It cannot be the answer. Use your brain critically. Why can 8.75 not be the answer? Think about the question. Am I getting an O? Oh my God. Can you cut 8.75 from 8.5? No. Okay, so that was really tricky because both are positives, but this number is outside the range of possibility. So in that case, we're only cropping 1 inch from each side. 1 inch will be cropped. That was a nice little challenger.